Good morning, all of you. In this class, we'll study how to calculate the equivalent mass of oxidizing agents and reducing agents. In redox titration, for example, K104 oxidizing agent is titrated against the reducing agent ferrous ammonium sulfate. In order to calculate the normality of oxidizing agent or reducing agent, equivalent weight is required to calculate the number of equivalents. What is equivalent weight is obtained from molecular weight. What is the relation between molecular weight and equivalent weight? Molecular weight equal to equivalent weight into N. Okay. Here N for acids, it is N is basicity. For bases, N is acidity. For oxidizing agents and reducing agents, N equal to change in oxidation number. In redox titration, there is change in oxidation number, whereas in precipitation titration, in acid-base titration, there is no change in oxidation number. So, in this case, for example, in potassium permanganate is reduced to oxidizing agent is reduced to Mn2 plus. The change in oxidation number, this is the oxidation number is plus 7. We will see how to calculate in the next slide. In acid medium, potassium permanganate is reduced to Mn2 plus. In basic medium, in neutral medium, the equivalent weights are different. We will see why. So, what are oxidizing agents? Reducing agents. For oxidizing agents are themselves reduced. Oxidizing agents, or for example, potassium permanganate is a powerful oxidizing agent in the acid medium. They are themselves reduced. You see, plus 7, it is reduced to 2 plus. Therefore, it gains 5 electron. Change in oxidation number is 7 minus 2, 5. Whereas iron, ferrous ammonium sulfate or ferrous sulfate dot 7H2O, ferrous is oxidized to ferric. Change in oxidation number is 1. So, reducing agents are themselves oxidized. They undergo increase in oxidation number. For example, increasing plus 2 to plus 3, whereas plus 7 to plus 2. So, they undergo, oxidizing agents undergo decrease in oxidation number. For in redox titration, there is change in oxidation number of oxidizing agents and reducing agents. How is this oxidation number plus 7 is obtained? I have shown here MnO4 minus potassium permanganate, that is K plus MnO4 minus, it is completely ionized, and X, let us calculate the oxidation number of manganese, X plus 4. There are 4 oxygen atoms. The oxidation number of oxygen is minus 2, therefore equal to minus 1, the charge carried by the ion. Therefore, X minus 8 equal to minus 1, X equal to plus 7. So, in potassium permanganate, the oxidation number of manganese is plus 7. Okay, and therefore, equivalent weight of oxidizing agent K104. The molecular weight is calculated by summing up the atomic masses of all the atoms present in the compound. For example, K, atomic mass of potassium is 39.1 plus atomic mass of manganese 55 plus 4 into, there are 4 oxygen atoms into oxygen 16, atomic mass of oxygen. On adding, the molecular weight is obtained equal to 158.1. Therefore, change in oxidation number is 5. Equivalent weight equal to molecular weight divided by N. Change in oxidation number is 5. Therefore, 31.6 is the equivalent weight of KMnO4 in acid medium. You see, in neutral medium, the equivalent weight is different. This is one of the common question asked in NEET JEE. Okay, please don't confuse. Depending upon the medium, depending upon the reaction, the equivalent weight changes. Okay. So you need to observe what is oxidized, what is reduced, okay, and ferrous ammonium sulfate. ferrous ammonium sulfate. This is ferrous ion is involved in the reaction as reducing agent. So ferrous ammonium sulfate, this is again called more salt, double salt, FeSO4 dot NH4 twice SO4 dot 6H2O. The molecular weight of ferrous ammonium sulfate equal to 392, equivalent weight equal to 392 divided by 1, change in oxidation number 1, therefore 392. As I said earlier, KMnO4, suppose KMnO4 in acid medium, KMnO4 is reduced to Mn2 plus. So change in oxidation number is N equal to 5. Therefore equivalent weight equal to molecular weight divided by 5. On the other hand, in neutral medium, you see, in the neutral medium, Mn, potassium permanganate, is reduced to MnO2. Therefore plus 7 to the change in oxidation number, that is plus 7 to plus 4. Therefore 3. 7 minus 4, 3. Molecular weight divided by 3. Therefore, potassium permanganate have different equivalent weight depending upon the reaction condition, reaction medium and reaction. Okay. Similarly, MnO4 minus in the basic medium, the titration, KMnO4 is reduced to potassium permanganate is potassium manganate. MnO4 2 minus, here MnO4 minus, this is permanganate, this is potassium manganate. This is plus 7, this is plus 6 in basic medium. The change in oxidation number is 1. Therefore, in basic medium, the equivalent weight of potassium permanganate is equal to its molecular weight. There are other oxidizing agents, potassium dichromate. In this potassium dichromate is reduced to, is converted to chromium 3 plus. Okay, so there are 2 chromium, therefore 2 chromium 3 plus. The oxidation number of chromium in Cr2O7 2 minus is plus 6 per atom chromium plus 6 in this ion, and for 2 per molecule, for 2 chromium atoms per molecule, therefore plus 12. That here also 2, because 2 is here, there are 2 chromium 3 plus ion, therefore plus 6. So change in oxidation number equal to N equal to 6. Therefore potassium dichromate, equivalent weight of potassium dichromate equal to molecular weight of potassium dichromate divided by 6. Okay, please remember why it is 6 not 3. Most of the students commit the mistake plus 6 plus 3, then they put 3, it is wrong. Okay, so per molecule plus there are 2, therefore plus 12. Similarly, chlorine is also a powerful oxidizing agent. Iodine is a weak oxidizing agent. Chlorine oxidizing agent, they are themselves reduced, so plus 2 electron gets to give 2 Cl minus, therefore N equal to 2. Number of electrons gained or number of electrons lost or change in oxidation number. It can be either number of electrons, for example plus 2 electron, 2 Cl minus, or 0 oxidation number. So change in oxidation number N equal to 2. Okay. Next, MnO2. MnO2 is also a good oxidizing agent used in many organic reactions. MnO4 in acid medium is reduced to Mn2 plus, and here change in oxidation number is plus 4 to plus 2. Therefore N equal to 2, change in oxidation number. And copper sulfate pentahydrate is another oxidizing agent, is commonly used against potassium iodide. It oxidizes potassium iodide to I2 and it forms cuprous iodide white precipitate. So it is completely ionized, therefore Cu2 plus is plus, it gains 1 electron, therefore, and also change in oxidation number N equal to 1. Okay, and hydrogen peroxide, another example is hydrogen peroxide. Hydrogen peroxide acts both oxidizing agent as well as reducing agent. With the Ki, with the potassium hydrogen peroxide versus Ki in acid medium, it acts as oxidizing agent. On the other hand, when potassium permanganate is titrated against potassium permanganate is a strong oxidizing agent. Therefore, it acts as reducing agent. See, it is oxidizing agent with the Ki. So, in the presence of acid medium, it gains 2 electrons to give H2O2. H2O2 gives H2O. So 2 electron is gained, therefore N equal to 2, or you can say we can also this here minus 1. Okay, 2 oxygen is there, therefore you put here 2 minus 2, and here 2 oxygen, 2 H2O2, therefore minus 4. Therefore N equal to 2, change in oxidation number or number of electrons gained by oxidizing agent. How to calculate the equivalent weight of reducing agents? Reducing agents are themselves oxidized. You see, ferrous ammonium sulfate, thiosulfate, they all lose electron. If they accept electron, they are oxidizing agent. Reducing agents are themselves oxidized. Okay. Thiosulfate, hydrogen peroxide versus KMnO4, oxalic acid. In ferrous ammonium sulfate, ferrous ion is oxidized to ferric, therefore change in oxidation number 1 or electron lost 1. And thiosulfate, sodium thiosulfate, pentahydrate, molecular weight equal to 248. This is ionized, sodium thiosulfate is ionized, S2O3 to give S4O6 2 minus, therefore 2 plus 2 electron. So in this case 2 electron is gained in this reaction, therefore N equal to, this is for 2L, that is for 2 moles N equal to 2. Okay, for 2 moles N equal to number of electron gained 2, but for per molecule then N equal to 1 only. Therefore equivalent weight equal to 248 divided by 1 equal to 248. When hydrogen peroxide is reacted with the KMnO4 is a powerful oxidizing agent, therefore it acts as reducing agent. So reducing agents are themselves oxidized, it loses electron, therefore hydrogen peroxide gives 2H plus O2 plus, to balance these 2 electron, therefore N equal to 2, molecular weight of hydrogen peroxide equal to 34, therefore equivalent weight equal to 34 divided by 2, 17. Oxalic acid, in the case of oxalic acid, it is dihydrate, molecular weight equal to 126. You also add the 2 water molecular masses of 2 water molecule, then molecular weight equal to 126, and it is completely oxalic acid versus sodium hydroxide, acid base titration. In that case, there are 2 replaceable protons, 2 ionizable proton here. Okay, so here also, there also in acid base titration, oxalic acid molecular weight divided by basicity. Basicity is the number of ionizable proton. It can furnish 2 H plus, therefore 126 divided by 2. In reducing agent, in redox titration, oxalic acid versus KMnO4, C2O4 2 minus is oxidized to 2 CO2 plus 2 electron. Okay, or reducing agents are oxidized, therefore 2 electrons are lost, and therefore N equal to 2, because balancing, if you balance 2 electron we need to add. Further, this reaction, this titration occurs only in the presence of heat. Why heating is required for oxalic acid versus KMnO4? Because COOH bond COOH. So there is a CC bond. In order to break the CC bond, an energy is required. This is endothermic reaction. Therefore, heating is required for this titration. We need to heat the reaction mixture oxalic acid H plus in the acid medium to 70 degrees Celsius, then only the reaction takes place fast because CC bond is broken when you heat. Thank you for watching.